Hello, welcome to lesson 2 of our first unit. Again, this will be sort of a review from grade 11, but today we're looking at interval notation and linear inequalities. So a few definitions to go through before we get to any actual math. First, there are 3 ways to describe a set of numbers. So those 3 ways are interval notation, the second one is inequality notation, and the third just being a regular sentence. So writing it out in words. Okay, how to write a range of continuous values in interval notation. So when we are talking about domain and range, we wrote XER, meaning in grade 11, meaning all real numbers. So it could be any negative number, it could be any positive number. But in interval notation, we write the furthest negative we could go, the furthest positive that we can go, both in brackets. So since it goes on and on and on forever normally, we write negative infinity, comma, positive infinity, meaning it goes to literally infinity both ways on the graph. Describe the set of numbers from -5 to +3 that includes -5 but does not include -3. So it goes up to 3, or sorry, +3. It goes up to +3 but does not actually include +3. So if it includes the number, so like the -5, we use these square brackets. And we know it goes up to 3 but doesn't include 3, so that would be the rounded bracket. Okay, describe the set of numbers demonstrated on the number line below. So we see in the first arrow, it's starting at 5 and going to the left, so the numbers are getting smaller, so it's going to be x is less than 5. But we notice that the circle at 5 is not filled in. It's an open circle. So that means it is x is less than 5, not x is less than or equal to 5. If it was filled in, we would need that equal sign as well. And then the second one also not an equal to, so it does not include 7, but x is bigger than 7. Okay, describe the set of numbers represented algebraically below. So we're describing what can happen here, and this is telling us that x can be any real number except for -1 and +4. Okay, given the function shown, so in the graph, we are going to find increasing intervals. So intervals is going to be brackets. Where is it increasing? So that means if we were to draw slope lines, so like the first part has a line that kind of goes like this, that is a negative slope. Then it turns into a positive slope and then back into a negative slope. So increasing means when is it a positive slope? And for that, we look at the 2 turning points, the x values of the 2 turning points. So we see that it turns into a positive slope at 0.785. And it goes all the way up to 7.215 before turning back into a negative slope. Okay, so then when we're looking at the decreasing intervals, we have 2 of them. Right? There's 2 separate areas on this graph where it's a negative slope. The first one, we don't know where it starts, so we'll say it's negative infinity. We're going to assume that the graph goes on and on and on forever. and the turning point is 0.785. And if there's more than one, we put this U shape in between the two brackets, and we see at 7.215, it then goes to negative again, and we don't know where it ends, so we'll say to positive infinity. Okay, great. C is the positive intervals, which means when the function is greater than 0. Okay, so this pink line represents 0. So when is the function above that line? So again, at the very start, we don't know how far left it goes, so we'll say negative infinity, and then it crosses 0 at negative 2. So negative infinity to negative 2 is positive, and then also it goes above the axis line at 5 and back down at 9. So it's also positive from 5 to 9. Okay, and then where is it? A negative interval. So we have negative 2 to 5, and then 9 to positive infinity. Okay, functions and function notation. There's going to be some definitions here. A function is a relationship or expression involving one or more variables in which each independent variable has only one dependent solution. Okay, so each x value can only have one y value answer. Okay, the vertical line test.
Mr. Barlow, please call the office. Mr. Barlow, call the office, please.
Sorry about that. If any vertical line on a polynomial graph crosses two or more sections of the polynomial line, it is not a function. Okay, domain is a representation of all included independent remember independent is x, independent values within a function. And finally, the range is almost the same, a representation of all included dependent values in a function. All right, function notation. Using a specific input to determine a resulting solution or output in a given function. So knowing a specific x value, plugging that into the function to figuring out the y value. So for an example, in the function fx equals 2x, what this tells us is f is the name of the function. The x, or whatever is in the bracket, is the input. And everything after the equal sign represents what the function does to find the output. Okay, so what this function does is just multiply the input by 2. Okay, if the function fx equals x cubed minus 9, let's find the specific input of -2. Okay, so what it tells us is we're going to replace the x with -2 and then use bedmass. -2 to the power 3 is -8, and -8 take away 9 is -17. Okay, B, the value of such that the function equals -17. So this time the number we're given is not in the bracket, so it's not the input. It's telling us that the output is -17, and it wants us to find the input. Okay, so it's saying -17 equals x cubed minus 9, and for this, we're isolating x to find the input, so we'll be using SAMDEB. So we get rid of the -9 by adding 9. And then we get rid of that cubed by cube rooting. And the cube root of -8 is -2. Okay, so work backwards. Consider the function shown in the table below. Find f of -2. Okay, so f of -2, so it's telling us that -2 represents our independence, or x's. So we look for when the independent is -2, and the answer, the solution, the output is 7. Okay, determine the value of x such that the output is -1. Okay, so there's where the output is -1. So that means the input was +1. Determine whether each of these is a function. Determine the domain and range. Okay, so this first one, vertical line test, doesn't matter where we put it. It never crosses the line more than once. So it is a function. Okay, and our domain Here, there's arrows on both sides, meaning it goes left and right. It doesn't say that there's an asymptote at 2, although it kind of looks like it, but we're going to assume XER. X is equivalent to all real numbers. Same with our range. Okay, arrows on both sides, so it goes on and on and on forever. We can guess that -2 is probably an asymptote, but we don't know for sure, so we'll leave it as YER. Okay, in the mind map, we have 5 inputs and 4 outputs, but each of the inputs, so the X values, only has one arrow coming out of it, so it only has one solution. That makes it a function. So even though 2 arrows both have an input of +1, it doesn't matter. All of the inputs could have the same output. You just can't have 2 outputs for each input. Okay, and then the domain, because it's an actual list, we list the numbers. So the domain is -2, -1, 0, 1, and 2. And the range is 0, 1, 2, and 3. Okay, this last one. Y equals 1 over x squared. So this is a rational. And a rational function is a function. So we learn a little bit about rational functions. In grade 11, it doesn't matter what you put in at x, you're going to get a different y every single time. Okay, the only things that it can't be, x cannot be 0. Right, because 0 squared is 0, you cannot divide by 0. So remember, in grade 11, when we looked at rationals, that gave us an asymptote at 0. So the lines approached 0 but never actually touched it. So our domain here is x can be everything, but it can't be 0. Okay, and then we'll learn further in this class that this function also has a horizontal asymptote at y equals 0, so y also cannot be 0. We'll worry about that later on. Okay, Bob rides a Ferris wheel that has a diameter of 6 meters. The axle of the Ferris wheel is 4 meters above the ground. The Ferris wheel takes 90 seconds to make one complete rotation. And Bob rides it for 10 rotations. Okay, so that's going to be key. 90 seconds per rotation for 10 rotations. What are the domain and range of the function that models Bob's height above the ground in terms of time while he rides the Ferris wheel? Okay, so the information we need to know for domain is highlighted in blue. So the domain, it can be decimals, or you can ride it for 3.5 seconds. So we're going to put YER. However, he starts at 0 seconds and ends at 900 seconds. Right, 90 seconds per rotation, 10 rotations. The range is highlighted in red. So again, you can be 3.5 meters off the ground, so it can be decimals. Okay, so it's saying the diameter is 6 and the axis line, the middle line, is at 4. So that means it's 3 on each side of the axis line, so it has a minimum of 1 meter and a maximum of 7 meters. Okay, so if you're not understanding that, here's the Ferris wheel. The middle line is 4, and it needs to go up 3 and down 3 to give us a diameter of 6. So that means max is 7, min is 1. Okay, parent functions. Parent function of a linear function is just fx equals x. So if we made a table in -2, -1, 0, 1, 2, the answer is exactly what you see. There are no changes, no transformations to this. Okay, so -2 is -2, -1, 0, 1, 2, and so on. So there's a parent function. Okay, of quadratics, it's fx equals x squared. Okay, -2 squared is 4, -1 squared is 1, 0, 1, 4. Okay, parent function of quadratics makes a parabola.
Lisa Bennett, call for you on line 110. Lisa Bennett, line 110.
Okay, we have exponential where we're using a base 2. Okay, so 2 to the power -2, remember negative exponents flips it, so reciprocals, so this will be 1 over 4 to the power -1 will be 1 over 2. Anything to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4. Okay, so 1, 2, 4, but then we have half, quarter, and it just keeps cutting in half all the way. So exponential gets close to 0, never actually touches 0, and goes up like that. Square root function or radical function is the square root of numbers. So let's go 0, 1, 4, 9, 16. So I'm giving actual rootable numbers for x's. Square root of 0 is 0, 1 is 1, 4 is 2, 9 is 3, 16 is 4. So it looks like that. Okay, and we're almost done. Absolute function looks like that. And everything, doesn't matter if it's positive or negative, whatever the x is, you give it a positive answer. Okay, so it's like two linear lines that make a V. Everything is positive. And finally, reciprocal functions. 1 over x. Okay, and this is what we were talking about above. Sorry, I said rational above, I meant reciprocal. So 1 over negative 2 is negative 1/2, negative 1. Okay, you can't have 1 over 0. Okay, so this is the one where we have asymptotes. At x equals 0, and y equals 0. Okay. And then the last two we learned last year, sinusoidal and cos. So we have sine x. And remember the x values here go by degrees. So we have 0, 90, 180, 270, 360. And with sine, they are 1, or 0, 1, 0, negative 1, 0. Okay, so 0, let's see, this is 1, negative 1. 0, 1, 0, negative 1, 0. And it does it backwards too. Negative 1, 0, 1, 0. Okay, and then cos is almost the same. It's just that cos starts at 1 and ends at 1. Okay, there we go. Those are the parent functions. Okay, that's a quick review of grade